Hello learner, welcome to Manifested e-learning platform. Today, ladies and gentlemen, we are discussing financial modeling and data analytics, December 2024. Let's start out by analyzing question 21. As a financial analyst at Apex Investments, you are tasked with constructing a minimum variance portfolio using historical return data from 4 different assets. The returns for these assets are given for the last 12 months, and you can be able to see them in this small table right over here. We have the assets A through to D and the months given to us here for 1 year. Assumptions. The risk-free rate is 14%. Your goal is to create a portfolio with a target expected return of 12%. Number 3, the minimum variance portfolio will be plotted on a risk-return graph, including the efficient frontier. You are required, A, to compute the following metrics based on the historical return data. Number 1, average return on each asset. Number 2, the standard deviation for each asset. Number 3, covariance matrix for the assets. Number 4, correlation matrix for the assets. In part B, you are required to calculate the weights of each asset in the minimum variance portfolio. C, we are required to perform a performance portfolio attribution analysis to assess the contribution of each asset to the portfolio's overall return and risk. As usual, let's move towards the right-hand side over here and solve the question. So we start out with part 1 here. Copy that, put it right over here. And we're saying that the average return for each asset class is going to be computed as follows. We will first of all pick the assets right over here, copy, and include them towards the right-hand side over here. Control V, that. Of course, we'll expand it, that. And for us to compute the average for each asset class, we just use the average function. So we'll have average, like so. And we could, because it's asset class A, just pick like that. We close the brackets. Enter. And we can see it's 21% given to us there. So because they're following each other side by side, if you drag it across like that, then you're seeing we'll get the corresponding average returns there. Put it maybe perhaps in all border format like that, to just for presentation purposes. In part 2, we are required to compute the standard deviation for each asset here. So copy this, move towards the right here. Standard deviation for each asset. And here, the standard deviation for each asset, we will use the STDEV or standard deviation function. And here we will copy this, subtitles here, that. And then we use STDEV for a sample, because we're using a sample data. We're not using it for the entire population, for sample like that. So just double click that and we pick that information, because these are returns. We've been told that these are returns. So we look for standard deviation of returns. Enter there. And because we want it, of course, in a much more in a percentage format, we are saying these are the values what I get. In part 3, we are told to compute the covariance matrix of the assets. So we come copy right down here. So the covariance matrix we will need to go to the data tab right here. You can see this data tab right here. Click on it and we go to data analysis. Once we go to data analysis, we give it a few seconds there, and you can see covariance has been given to us right over there. And what we do, we click on covariance and we say, okay, the input range will be from right here all the way down here. We exclude the months. So we are going to group them by columns, and labels in the first row, we check that box right there, like that. And we want it in a new worksheet, so that now I can copy that from that worksheet and place it right here, part 3. So we say, okay. So we are saying that this is what we have. And because it's, of course, in the Excel format, rather not Excel format, we want it in Times New Roman, like that. Of course, I didn't put it in Times New Roman, and then of course 16. That this is exactly what we want now, guys. And then we do not want it in italics, so of course put it like so. So just copy this, copy, place it right here, right down over here, Control V. This is what you're saying the covariance matrix looks like. Put it like that. With this information then, we can proceed on to part 4, right here. Of course, this one needs to also be that format here. We can also put this perhaps in a much more presentable format, like so. There. Let's move on to part 4. Correlation matrix for the assets. Copy this. Copy. Right here. Then, when getting the correlation matrix, if you're keen, you may have seen under the data tab, data analysis right over here, the correlation component. We say, okay, the input range, similar to what we've just done. This is the input range. Check on the labels, first row. We also want it on a new ply worksheet, and then we'll copy it onto this worksheet. Say, okay, give it a few seconds. And we already have the correlation matrix given to us there. So come home. We want it times New Roman. And then we're talking about 16, like that. Copy. And then we come to question 21. Move towards the right here. Place it there, Control V. You can be able to clearly see this correlation matrix. Now, once we have that, we can move on to part B of the question. Part B reads as follows. Calculate the weights of each asset in the minimum variance portfolio. So we copy this here, the way it is. Over there. So we are saying that we need to proceed on, because part B, the weights of the assets using the minimum variance portfolio, we need to use solver setting. Solver settings under the data tab right here. And you can see the solver is right over here. The first thing that we need to do is to get, first of all, these asset classes listed to us right over here. Copy. Just list them down over here like so. And then So of course, home format painter, we want it like that. We get the portfolio weights. To get portfolio weights, portfolio weights, right here. So we will need, perhaps we may need to just drop this down a bit. Weights, the variance, and returns, like that. So once we get the variance, then we'll be able to now calculate the portfolio. We calculate the weights of each asset, the minimum variance portfolio. We'll also need to use this so that we can be able to calculate or perform part C over here, performance attribution analysis. So here, solver, the weights over here, we are saying that they should add up to 100% plus sum. We're getting the sum of what? Of all of these values right over here, like that. Should add up to, so that now if we put, maybe say, of course, over here, we'd want this to be in percentage form over here, like that. Oops. We would want these ones to be percentage form, like that. So we put 10, 20, 50, and over here, this should also be in percentage form. These are just arbitrary values. So I'll need 20% over here, so 20. So that now we're seeing we talk about 100% right there. So the portfolio weight should add up to 100%. But we don't have these weights here. What do we need to do to be able to get the weights? We already have the returns given to us over here, and we've calculated them right above over here. Sorry, excuse me. These ones here. So I just copy these. Copy. And then we are saying, no, if I copy these ones over here, we need to look for combinations that give us maximum returns right over here. That's what, yeah. We should just copy this. So paste special. And you can see we want the values. Yes, I copy the values, not all, but I want to transpose them. Transposing means to convert them from into rows into now columns. That's what I'm transposing. So initially they were like that, but now I've converted them into one column. I'm like so, like that. And of course, these ones are returns, and you're saying that these ones should be percentage, like that. Like that. So how do we get the portfolio returns? We will need to get the sum products. The weight, this one times expected return plus that one times that one plus that one times that one, and so on and so forth. That is the same as getting what? Sum product. Sum product. But we still don't have the weights. So sum products, we still need to first of all just arrange this information the way I'm just informing you politely. We get the weights here for array 1. And then array 2, we will also need to get the returns. Right there, up to there. And we say, okay. So, but we'll need to get the sum. Why would we have 0? Because we don't have anything here. Remember, we are saying to get the sum product is just the weight times expected return plus this second weight times expected return plus this third weight, and so on and so forth, like that. So we have 0 because we don't have anything to do the weights here. If we had values here, then obviously we'll be able to get the returns right over here. Now our next step is to proceed on to get the variance right over here. The variance is just standard deviation squared. So we're saying we have the standard deviation. Where did we calculate the standard deviation? Can you remember this standard deviation part 2? That one squared. Power 2. There. We're getting that value. So it's just that one power 2. It's just this one power 2. Just this one power 2. Then we enter that. Please note that getting the variance of returns for these asset classes needs to consider, they need to consider the standard deviation formula and also the covariance matrix right over here. Remember, covariance of A and B, covariance of A and C, covariance of A and D. Then you need covariance B and C, covariance B and D. Then you also need covariance C and D, like that. That's what you need to calculate or to consider when calculating variance. To put it into perspective, let's work it out together. So we're saying the first thing is for us to perhaps recall the formula, or we need to first of all get get the variance of returns right over here. So we first of all get the weight, standard deviation squared times weight squared plus standard deviation squared of asset class B, weight squared, and so on and so forth, like that. That's the long formula you're going to get that. So this one, we want it squared. And we are multiplying that with the variance. Remember, variance is what? Standard deviation squared. So we'll just multiply that directly, like that. So we pick the following, like so, and you put it in, of course, brackets, right over here. So weight squared, standard deviation squared, times standard deviation squared, or variance. I've just picked it, and I've not put it squared there because it's already squared, plus that one squared times that value, because it's already squared. You need to put that also in brackets, plus that one times squared, squared. Do not want to miss the squared. So this is squared, and this should be squared, times that, close the brackets, plus, open the brackets, that one squared times this value right over here, close the brackets now, plus 2 times, now weight of A, standard deviation squared of A, times covariance of the first combination, second combination, third combination, and so on and so forth, like that, plus 2 times, and I open 2 brackets. So I'm talking about the weight there times, not squared, so the weight times the weight of B, that one, and then we look at A, B, the covariance of A and B, times the covariance of A and B. Where do we get the covariance of A and B? The covariance of A and B is there, right there, and you can be able to see it right over here, guys. I hope we are moving together. So we click that one there. We close the brackets. And then we add A and C. So we add A and C. So, excuse me, we open the brackets, A and C. So that one and C times C, because we've already done A and B, so A and C times the correlation between A and C. A and C is that one. Covariance, excuse me. Close the brackets. Plus, we open the brackets. A and D times D times looking above over here, times the combination of A and D is that one there, the covariance. So we pick that there. Close the brackets. Plus, we're not done yet. We'll need to pick, now we've done A and B, A and C, A and D. Now we'll need to pick B and C, B and D. So we pick B times C times the correlation between B and C. And which one is the correlation that relates to B and C? We're talking about this one here. That one there. Close the brackets. Plus, we open the brackets again. The combination of B times D. Like that. Times, we look for B and D. B and D is right here. There. Plus, we are not done yet. One more to go. We're looking at the combination of C times D times C and D is here. That one there. We close the brackets. And we close the brackets again because we were opened over here. Two opening brackets right over here, you can see here. And then we say enter. We'll obviously have 0 because we don't have weights given to us over here like that. So what are we saying then, guys? We are saying that now we can be able to compute the weights of each asset in the minimum variance portfolio. So let's proceed now and try and identify the weights over here. We go to data, and then we go to solver, and we set our objective. Our objective is we want to set, our objective is to set, we just try and check, just 1 second, we try and check if there are any constraints. So your goal is to create a portfolio that target expected return of 12%. That's what we want. So the minimum value will be plotted. Yeah, your goal is to create a portfolio that target expected return. So, so we can come over here and say, solver, our objective of these returns is to set it to a value of 12%. So minimum, no, not to minimize, is to set a value of 12%. 12%. That's 41, so it's this one here. By changing which cells, by changing cells, these are the cells which will be changing. And we need to set up a constraint over here. So we add a constraint that this value should equals to 100%. Then we can add another value there and say that these values should be greater than or equal to 0, should be greater than or equal to 0%, like that. And then we say okay, because we've said we've set these values to be 0%, greater than or equal to 0%, and this value should be 100%. Let's solve. So we say okay, initially it tells us 95%, but remember we want this to be 100%. That's what we want. We want the sum of these to be 100% there. So we just try and check this question right again. So we delete that. So let's proceed on and analyze it again. We're saying we come to solver, we set the objective. Our objective is to minimize this variance right over here by changing which cells, by changing these cells right over here. But we have some constraints. We add the first constraint is that this value, portfolio weights, should equal to 100%. Then we add and say that these values should be greater than or equal to 0. Should be greater than or equal to 0. Should be, in other words, there should be positive values there. And we say okay with that information, and we test and see if indeed this gives us the minimum variance. We solve, and you can see it has actually given us some weights right over here. A total to 100%. It actually minimizes the variance right over here. You can see the returns it has given us right over here is 18%. So we are saying that with this information, we can then proceed on to part C, to solve part C. So let's put this, of course, in Excel format, this, or in a table format. We move on to part C. Copy this. Part C right here. We are required to perform a portfolio attribution analysis to assess the contribution of each asset to the portfolio's overall return and risk. So that for us to be able to perform a performance attribution analysis, we need to get, first of all, the asset classes over here. So copy this. As well as the weight. So we copy those values like that. Copy, put them down here. That. So class, put the weights, and then we get the expected return, the returns. Copy, because we already have computed the returns. We just copy this column the way it is. Copy up to there. The standard deviations, we already have the standard deviations calculated for us right over here, and you can see the standard deviations right over here. So we just pick them from here, copy, and then when putting them right over here, we can just paste special like that. We want the values and we want to transpose them. They're there. Put in like that. Now, for us to be able to calculate, so of course this is, you can see that this is the standard deviation. Standard deviation. That. Of course, you don't want it boldened. Once you have the standard deviation, the next thing or the next item for us to be able to calculate is the return contribution right here. Because we've been told performance attribution analysis to assess the contribution of each asset to the portfolio overall return and risk. So we look at return contribution and risk contribution. Like so. And we're saying that the return contribution in form of percent, we'll just pick the weights over here and we multiply by the expected return right here. That's it. So in this case, 0, and of course we're talking about, we drag it down like that, it gives us the form of a percentage, 2 decimal places, like that. For us to be able to calculate the risk contribution, we'll now need then to pick some certain values. We need to do some computations right here. So we are saying, of course we'll do the formatting later. We'll need to pick the weight right there. And then we square that, multiply that with the variance. Variance there. Close the brackets. That. And then we open two brackets like so. The weights for B, talking about in terms of this weight over here for B, like that, because you can see it's 33%, no problem. Or you can even pick this one over here like that. So let's pick this one over here like that. And then we multiply that against what is called, these are, we'll need to pick the covariance matrix. Yes, covariance matrix right here. Right here. Covariance matrix, this component right here. Close the brackets. And then we add the weight for asset class C. We will not open that. Asset class C, and then multiply that with the corresponding covariance. Covariance there. And then we add, finally, the fixed income investment there. Multiply that with what you can say the investment in fixed income, which is here. Close the brackets. So, because there are two brackets we've closed, we close them like that, say enter. That's the risk contribution. Put it in form of percentage. Put it like that. And those are the risk contributions that are given to us there. So the rest is just now putting it in, of course, in a format painter like that. Now present it like so. And that's how we perform a portfolio attribution analysis to assess the contribution of each asset portfolio's overall return, we've seen there, and the risk components right there. So this brings us to the end of FMDA that came in December 2024, question 21. Bye-bye.